Okay, let us proceed to question number 3. We are asked to find the derivative of 1 all over x. You see, all you have to do first is to set a letter equals to 1 over x. You understand? So let's say c equals to 1 over x. I intentionally use another letter, you understand, so that you can use y, you understand, but I intentionally use another letter because we are not given the equator, you understand. We are not told that this function is equal to anything, so you can use any letter, okay. So here I'm using t, I'm not using y, okay. Now in an attempt to solve this question, the first step is that we have to increase, don't forget, we are differentiating with respect to x, you understand. Now the first step is that we have to increase x by delta x. That means I'm going to replace, anywhere I see x in equation 1, I'm going to replace that with x plus delta x. And there will also be a corresponding increment in t by delta t, you understand. So I'm going to have t plus delta t is equals to 1 all over x plus delta x, okay. Now having done this, please kindly pay attention. The next step is that I'm going to make delta t the subject of the relation, okay. So I'm going to have delta t is equals to 1 over x plus delta x. Now if this t crosses the equals to sign, the positive sign is going to change to negative, so I'm going to have negative t, okay. Now don't forget that t is equals to 1 over x according to equation 1, so I'm going to have delta t is equals to 1 over x plus delta x minus 1 over x, because according to the first equation t equals to 1 over x. So what I did is that I just replace negative t by 1 over x, you understand. Okay, now having gotten to this point, the next step is that you have to take the LCM of both sides, both fraction, okay. So if you take the LCM will be the product of the denominator, okay. So I'm going to have x plus delta x multiplied by x, okay. Okay, let's put delta t. Delta t is equals to x plus delta x multiplied by x, okay. X plus delta x multiplied by x. Now this product divided by each denominator, you understand, just like the example that I got here, 1 over, if you are to take the LCM of 1 over 3 minus 1 over 2, the LCM will be what? 3 times 2, you understand, which is 6. 6 divided by 3 will be what? 2. 2 times 1 will be what? 2. Now using the same approach, this product divided by x plus delta x, I'll be left with what? X. Just like saying like x plus delta x multiply by x divided by x plus delta x. This will cancel this, so we are left with what? X. This x multiplied by 1, that is what? X. So I'm going to have x minus, now this x plus delta x multiplied by x divided by x, that is what? X plus delta x. X plus delta x multiplied by 1, that is what? X plus delta x, you understand. Okay, so this is what we are having now. Now the next step is that you have to simplify the numerator, okay. So I'm going to have delta t is equals to x minus delta x. What did I do? I just use this negative sign to open the bracket, okay. So I'm going to have all over x plus delta x multiplied by x. So for this, I'm going to have delta t is equals to x minus x is what? Negative delta x. Negative delta x all over x plus delta x multiplied by x, okay. Now having gotten to this point, the next step is that you have to divide both sides by delta x, okay, or multiply both sides by delta x, you understand. The reason why we are multiplying both sides by delta x is that the goals of the question is to differentiate the function with respect to x, okay. So in an attempt to do that, we divide both sides by delta x or multiply both sides by delta x. It's just like saying that 1 over delta x multiply delta t. I'm going to have delta t all over delta x, you understand, and this multiply 1 over delta x, you understand. I'm going to have this delta x will cancel this delta x, so I'm left with negative 1. Negative 1 all over x plus delta x multiplied by x. You can see that I've not done anything, you understand. So that is it. You just have to pay attention, you're going to understand. Okay, now having done this step, the next step is that you have to limit delta x as it tends to 0, you understand. So here I'm going to have dy all over dx limit delta x as delta x tends to 0. So I'm going to have delta y. Oh, sorry. sorry. That is the t, okay? The t all over the x. I forgot that I'm using t now, okay? So I'm going to have delta t all over delta x is equals to -1 all over x plus 0 multiplied by x, okay? Because the meaning of this is that anywhere I see delta x, I'm going to replace it at 0, okay? So I'm going to have dt all over dx is equals to -1 all over x plus 0 is what? X. So I'm going to have x multiplied by x, okay? So here I'm going to have dt all over dx is equals to -1 all over x squared. So the derivative of 1 over x using the first principle is -1 all over x squared. You can also use the polynomial rule or the power rule to check maybe you are correct. How do you do that? Don't forget that if t equals to 1 over x, t can be written as what? X raised to the power of -1 according to the laws of indices. And according to the polynomial rule, the power is going to reduce by 1. You understand? And the power is going to multiply the coefficient. You understand? The power is going to multiply the coefficient of x, and the power is going to reduce by 1. That is, we are going to subtract 1 from the power. Okay, so here the derivative of t will be equals to -1 multiplied by x raised to the power of -1. Hope you know, because the power is what? Already negative. So we are also subtracting the -1 that we have to subtract using the polynomial rule. Okay, so here I'm going to have the derivative of t is equals to -1 multiplied, okay, negative x raised to the power of -2. And this can be written as -1 all over x raised to the power of 2. You understand? According to the laws of indices. Okay, so that is it. You see, in understanding differential calculus, it is very important that you understand the basic rule. Okay, that is number 1, the power rule; 2, limit; number 3, chain rule; number 4, product rule; number 5, logarithmic differentiation, quotient rule. All these are important in simplifying a complex differential calculus question. Okay, so and you might come across question that they will specify that use this so rule to differentiate this function. Now if you didn't understand all this rule, how do you want to differentiate it? Okay, so kindly watch those classes that we've done. Okay, now this is the solution to the question. Okay, so we are left to go to question 4 and question 5. I'm going to take the question 5 and we are going to go to question 4 now. Okay,